All right, here's the first page of the assignment key. We'll be going through one page at a time. I think that'll be easier to upload anyway. So our first question asks us to find the prime factorization, and prime factorization means don't stop until we reach prime factors. So I'm only going to divide by primes. I'm going to do this using the tree because you guys seem to like it. I'll divide this one. It's an even number, so I can divide it by 2. 4116 by 2 should be 2058. It's even again. I can divide by 2, get 1029. That's not even, but I can divide by 3, get 343. And 343 I can divide by not 3, not 5, but 7. So by 7 should get me 49. And 7 and 7. So I have my prime factors here, 2, 2. So it's 2 squared. So I know it's going to be that one or that one. And I've got 1, 3. And so that one has 1, 3, and that one has 1, 3. That didn't help. And I've got 1, 2, 3 7s. So that's 7 cubed. This one has 7 cubed. So my answer's got to be B. This one only has 7 squared, but there's 3 of these guys. Next, I'm going to erase this. If you need to look, go back in the rewind. Next, determine the GCF for 56 and 88. So if we're finding greatest common factor, I really like to do that method that's got a million names, but I call the ladder. These are both even. I can divide by 2. 56 by 2 is 28. 88 by 2 is 44. I'll write that a little bit nicer. Those are both still even. So I get 14 and 22. And now I can go by, well, 2 again. They're even again. 7 and 11. And now that's the last where I can find only common factors. 7 is a factor that is only applicable to 56. And 11 is a factor that's only applicable to 88. So these guys here are the ones that are in common between the 3. So my GCF is going to be, 2 times 2 times 2. And 2 times 2 times 2 is 8. So that'll be D. B, D, you can circle that, sure. So I use the ladder and I stop for GCF. Stop when you don't have common factors. For LCM, here we're looking for LCM, 78 and 102. At this point, I'm going to keep on going all the way to the end. So 78 and 102. I can divide by 2, I get 39, and 102 by 2 is going to be 51. Now I can go by, these are both 3s, sure. I can go by 3, so you get 13 and 17. 13 and 17 are both primes, so I know that that's all I can do. And once I'm down to 1s at the end here, I'm all finished. And my LCM is going to be the product of all of these guys here. So 2 times 3 times 13 times 17. 2 times 3 is 6 times 13 is going to be 78. And then times 17 is going to be 78 times 17. It's going to be 1326. Is that one of our choices? It is. Good. So it'll be A. All right. Number 4. So GCF, we did the tree method and we stopped before, or when we had no common factors. LCM, we did the tree method and we kept going until the very end. So we had 1s only at the bottom. Question 4, what's the side length of the smallest square that could be tiled using a 6 by 15 centimeter tile? So if we have a 6 by 15 tile, 6 by 15, and I'm trying to tile a square, that means I'm trying to lay these out in such a way that I get a square in the end. So that probably won't work just doing something like this. Probably I can't do something like this. I probably have to lay out a bunch of tiles. So we could draw it if we just had some grid paper, some graph paper, and I just did 6 by 6 by 15, and I just drew out the tiling to see how big it would be. But really this question is asking me about lowest common multiple, or least common multiple. So I'm going to take 6 and 15, and I'm going to find LCM. I can divide by 3 and get 2 and 5, and then those are both prime, so nothing to do but pick them off one by one. So 2 times 3 times 5 is our LCM. So 2 times 3 times 5 is 6 times 5 is 30. So 30 is our LCM, which means that the smallest side will be 30 centimeters across, so C. So that could be done by like a 15 here and a 15 here. 15 and 15 is 30, and this is 6, and I would have 1, 6, 12. So 6 and 6 is 12, and 6 is 18, and another 6 is 24, and another 6 is 30. So 1, 2, 3, 4, 5 tiles by 2 tiles. This doesn't look like a square, but it's only because I didn't draw it right. If I drew it to scale, or on graph paper, which is the only way I could possibly draw it to scale, I would be able to show you it's a square. Next, number 5 here, a cube has a volume of 15,625 cubic centimeters. What's the surface area of the cube? So for a cube, we've got a cube. We know volume of a cube is length times width times height. That's an L over there in case you're wondering where my scribbles are. And length times width times height. If it's a cube, we know they're all the same. So one side cubed. So I want to know how long each of these sides are, because when I'm calculating surface area, that'll be important to know. So I'm going to take the cube root of 15,625 centimeters cubed, and the cube root of 15,625 centimeters cubed. I'll just ask my calculator this time, and I'll get 25. Each side is 25 centimeters across. I'm just going to pause here to make sure that we focus in on this unit for a moment. If I take the cube root of just the unit, centimeters cubed, I'm asking what times itself gives me centimeters cubed. And that answer is centimeter times centimeter times centimeter is centimeters cubed. So the cube root of the unit centimeter is just one of those, centimeter. Cube root of centimeter cubed is centimeter, which is really saying measuring the side, one side of a cube. So each side is 25 centimeters, which is a number that shows up here. If I could only use the highlighter, there we go. But it's centimeters squared and not centimeters. That should be a big warning sign if you're not getting the right unit. In fact, we need to find area, which will be a square unit. But for area of one square, one of these faces here, so just take the front maybe, that area will be just like for any other quadrilateral, length times width or base times height. In this case, they're the same, so we could say side squared if you like that formula better. And that's 25 centimeters for this measurement times 25 centimeters for that measurement. So 25 times 25 is 625. The area of each side of the cube is 625 square centimeters. But there's not one side to a cube. There's 6. A cube has a front, a back, a top, a bottom, a left, and a right. There's 6 sides. So I have to take this 625 square centimeters and multiply it by 6 different sides. And that should give me 3750 for the numbers, and centimeters squared has nothing else to multiply by. There's no unit here. So I should get 3750 square centimeters, which is there. It's B. And again, if you want to go over any little bits, make sure you just hit the rewind. It's a great feature for video. Question 6 just asks you to evaluate the cube root of -64. So it's not impossible. It would be impossible if it was the square root of -64 or the 4th root of -64. If there is a square, a 4th, 6th, any even number for the index, we can't have a negative number inside. But here, sure, cube root, go for it. So it's definitely possible for a cube root. It's asking you what times itself is equal to -64. And that answer is going to be, well, 4 times 4 is 16, and 16 times 4 is 64. So it's got to be -4. So if we put in -4 times -4 times -4, we should get -64, which shows up here, -4. Good. Come on back. All right, I'm going to stop recording for this page and move on to a new video for the second page.